Example 1. Eventually, we'll learn some nice techniques for graphing. Just like with lines, you learned y equals mx plus b. You learned that b was the y-intercept and m was the slope. And so you were able to graph things starting at the y-intercept and using your slope. We're going to learn techniques for parabolas as well. But a technique that you always have, that you've had with lines, that you have with parabolas, that works with any kind of function you want, so you can graph anything, is a table of values. A table of values set up with your x and y. You choose values of x and see what y is equal to. The more points you choose, the more accurate your graph is going to be. Now, when you did a line, you only needed 2 points and you could draw a line because the line is straight. Usually your teacher probably said do 3 points because if you make a mistake on one of them, it'll show up because they won't line up in a line. But if all 3 of your points line up in a straight line, you know that you've got them right, and then you'll be able to graph it. A parabola is a little bit different because you're trying to find a vertex and you're trying to find some symmetry. So we start by putting in some values, and you can go until you find some sort of symmetry. So I find that plugging in 0 is always the easiest one to start with. What happens when I plug in 0? I get -6 because it's going to be 0 plus 4x minus 6 gives me -6. 1 isn't very hard to do with mental math. 2 times 1 plus 4 minus 6 is 0. Let's try 2. 2 squared is 4 times 2 would be 8 plus another 8 is 16. So now I've done 3 points. I haven't got any symmetry yet. Can you see that I've gone up by 6 and now I'm going up by 10? If I put in 3, it would seem like I would go up by even more. So now I'm going to try some negative numbers on the other side just to see if I can get some of my numbers closer together. So I've done 0, 1, and 2. Let's try -1. What happens when we plug in -1? 2 times -1 squared would be 2 plus a -4 minus 6. What does that give me? -8. How do I get 10 from the 2? If I would plug in 2, I'd have 2 times 2 squared plus 4 times 2 minus 6. And so this will be 8 plus 8 minus 6 and give me 10. You notice that when I went to -1, my numbers weren't as big? Like going from 0 to -1, my y values are -6 to -8. They're closer together. That tends to tell you you're getting closer to your vertex. So let's try another value, -2. When I plug in -2, 2 times the -2 squared plus 4 times the -2 minus 6. Order of operations, your exponent first. -2 squared will be 4. 4 times 2 is 8. 4 times the -2 is -8. That'll be 0 minus 6. Hey, we finally got some symmetry. So now we've got some symmetry. We're going to be able to graph this. We're going to be able to tell where our vertex is from that symmetry. So I'm going to draw my grid. I'm going to put some values on here. I have 0, -6. I've got 1, 0. And I've got 2, 10. I have -1, -8. And then I have -2, -6. So there's my symmetry with the 2 values that are at -6. Can you see that because these 2 values is where my symmetry is, my axis of symmetry would have to be right in between them? Does that make sense? On quizzes and tests, you'll get little graphing paper. Sometimes in your textbooks, they provide graphing paper. So because it's symmetrical, do you see that we have the point -1, 1, 0? We would also have, and that's 2 away from your axis of symmetry, 2 away this way would tell us you would also have a point here at -3, 0. Because we have the point at 2, 10, and 2 is 1, 2, 3 away from your axis of symmetry. If you went 1, 2, 3 in the other direction, you would have -4, 10. And if we drew this out, woo, okay, hopefully you're able to connect the dots better than I did. Maybe we can cheat a little bit. Oh, yes. Perfect. Perfectly drawn. I do. So now that we've drawn our graph, we can label some things on here. This is going to be an important point. This point -1, -8 is important because it's called our vertex. So now when we go through here, can we determine all of these things from our table of values? Are we able to say what the x-intercepts and y-intercepts are? Well, our x-intercepts for part I, that's where it crosses the x-axis. That happens at x equals 1 and x equals -3. We can find our y-intercepts from our graph. Our y-intercept is where it crosses the y-axis. It happens at y equals -6. That's when x is 0. Part 2. Can we find the coordinates of our vertex from our graph? We did. We found out that it was at -1, -8. Every time you write a coordinate, you make sure you have brackets around it, because that's how you write a point on a graph. Part 3, the equation of the axis of symmetry. When we have an axis of symmetry, anytime you have a vertical line, your equation is always x equals, and it's x equals whatever value it's going through. So it'll be x equals -1. So our axis of symmetry, the equation is x equals to -1. The domain of any parabola is always all real numbers. This is set notation. You can write it that way. Or you can write it in interval notation, which starts at a minimum value and goes to a maximum value. But since there's no minimum value, we say it goes from -infinity to infinity, saying that includes everything. More often this one is used in this case. X is an element of the real numbers. And finally, the range, in set notation, we would look, do we have a smallest value or do we have a biggest value? Since this parabola is opening up, we have a smallest y value. The smallest y value is at -8. So your range is all y values such that y is greater than or equal to -8. Or if you wanted to write that in interval notation, you start with your smallest value. Since it includes -8, you use square brackets. You write -8, and since there is no maximum value, it goes up to infinity. We always use round brackets with infinity. Okay. So to practice, 4, 5, and 7.